And we're live. Welcome, everyone. Super excited. Special edition Pixel Watch Teardown. We have some special guests. We've got some new members of Team Teardown here. Before we dive in to introduce the team, let's see who's in the crowd here. So housekeeping, Zoom chat 101, bottom right corner, that little blue bubble, change that to everyone and just tell us where you're calling in from. And we're talking about wearables today. So we want to hear about the first wearable that you own. This could be smart wearable, smart watch, first smart wearable. Let's start with the team here. David, let's hear about your first wearable.
First wearable, this goes way back. The Pebble watch. I don't know if folks still remember that thing.
The Pebble watch, yeah. What was your experience? Did you have fond memories?
Yeah, the OG, like the Pebble watch was pretty good. You could play a couple of games. I could get like little previews of text messages. Yeah, I don't know. It was pretty novel for its time, quite ahead of its time.
Nice. That was the one with the e-ink display, right?
Yeah, the battery life was, yeah, it was awesome. This thing would just go forever.
All right, excellent. Welcome, Miguel and Jim. We've got Fitbits across the board as first wearable. How about Nihal? What was your first wearable?
So I had kind of like a hybrid smartwatch from Fossil, where every time you'd get a notification, it would like blink blue underneath the watch face, and you get messages or Facebook notifications or whatever it was. Very quickly turned off those blinking lights because then your wrist is just flashing a lot. And it would vibrate, which was really cool.
Vibration in the smartwatch early on, that's pretty impressive. All right, yeah, for those filing in, we're talking about your first wearable device. So in the Zoom chat in the bottom right, change that to message to everyone and tell us about your first wearable. I was thinking back on mine. I was thinking watches and wearables. I do remember fondly, I had one of those little calculator watches way back when as a kid, but first actual smart device, I went through a phase of really not liking anything on my wrist. So I didn't jump on the Fitbit bandwagon. It wasn't actually until I was working at Apple and I found out that I was working on the first gen Apple Watch. And this was like super exciting, about a year out. And that's when I made a decision that I guess I'm becoming a watch guy now. And so I started wearing a dumb watch first, and then eventually to the first gen Apple Watch. So it was a pretty big jump for me to jump straight into a smartwatch. All right, let's jump into it then. Welcome everyone to Change Notice episode 17. So this is an extra special one. We've got David Kalinowski as a guest here. For those of you just joining in, again, bottom right, change that to text to everyone and introduce yourself and tell us about the first smart wearable that you owned. We see a lot of regulars in the crowd, so welcome back and welcome to the newcomers as well. This is our monthly teardown series. And the goal here is really to build a community, share knowledge, support the community, and really just work on continuous improvement. So a few reminders, if you do need to duck out early, please fill out that survey because that's how we decide what we're going to tear down next. Before we introduce the team here, again, as always, as with most of our past teardowns, actually, we don't have any insider knowledge that was provided to us on these devices, but we do have a great team of experts here that will analyze what we're going to find inside this watch. So let's jump into the team teardown here. Let's start with David. Tell us a little bit about yourself.
Yeah, I am a mechanical engineer by background. I've worked on cars over at Tesla, worked on a couple of drones, and worked on some wearables, very fitting for today. And most recently, I'm over at a company called Opal Camera. We make really high-end prosumer web cameras, and we're actually going to be streaming the teardown off of one of the cameras. Should be able to get some pretty great quality. Yeah.
Pretty awesome. Pretty awesome. Hi, everyone. My name is Nihal. I'm a solution architect here at Instrumental. My background is also in mechanical engineering, and I've spent majority of my career in medical devices, working at Johnson & Johnson and Abbott, designing cataract surgery machines and radiation therapy machines. So looking forward to tearing down this wearable with you guys.
All right. Welcome. Super excited to have Nihal first time on Team Teardown and David as our special guest here with a very impressive resume of past product design gigs. So I'm Tobias, host here, background also mechanical engineering, spent a number of years at Apple working on watches and phones. So for this teardown here, I can't help but compare each and every design detail to the Apple Watch. I do notice a lot of similarities in some of the designs, but also a lot of differences. So we will touch on those similarities and differences as we dive into this Pixel Watch today. So on the docket, we're going to go through the live teardown. We're going to discuss design decisions. We're going to have plenty of Q&A. So the goal here is to answer questions and share knowledge with you guys. So please, please, please post questions in the chat throughout, and then we'll have more Q&A at the end. So let's dive into it. I'll hand it off to David to give us an overview of what we have here.
Yeah, sure thing. Thanks, Tobias. So here we have our first generation Google smartwatch. Just give you guys a couple of looks around. So we have over here, we have a crown, rotating crown that you can also click. We have a button here. We have a port. I guess we'll find out what this port here is for later. Could be audio, could be an altimeter. We have a pretty interesting band attach mechanism where you press these buttons right here and you're able to slide and dislodge the band. Pretty unique, quite fancy. And then on the bottom side, we have Tobias. I'm sure this will bring back some fond memories, but we have a pretty interesting, probably health sensor hub down here. There is the box claims that it can do heart rate sensing. I believe there's something about ECG, and we can see some probably optical sensing, what looks like some shiny surfaces for maybe some electrodes. And on the other side, we have a speaker port and also another hole. And you can see the displays already excited to pop off. We pre-delaminated the display using a heat gun. So we use the heat gun and a lovely iFixit spatula over here to get that thing apart. So yeah, this is a kind of a quick once around on the product.
How are they, David? I know one thing that we saw in the questions was around what that glass shape looks like. I see up at the top there. How do they shape that glass around the crown?
Yeah, that'll be really interesting to take a look at and open up. It definitely looks like the glass and the crown have to coexist somehow. So maybe they cut a notch out of the glass. Maybe there's some funky geometry on the crown, but it will be really interesting to see what's going on there. There's also something to note is that this thing is a circle. We typically don't really see smartwatches in kind of these circular shapes with really curved. I don't know what's going on here with the cover glass, but there's some really interesting curved glass surfaces. So I'll be really curious to open this up and look inside.
Yeah, I think from the industrial design standpoint, that was the first thing that stood out to me as well. Is it has a lot of Apple Watch curvature, but it is the first, I think, in like a full 3D spherical glass. It looks pretty sleek. I'm not gonna lie. And then when you're talking about that notch on the crown there, looks like there's a question from Vivek about how the waterproofing works on this device. I think that's going to be really interesting when we look at that, what looks to be a notch around the crown and how that plays into waterproofing. So, yep, again, please post in the comments what you're most interested in as we dive into this watch, because there's a lot of stuff going on and we're just going to follow wherever you guys are most interested in. So let's maybe pop off that cover and see what we have underneath.
Yeah. So again, we use heat and our handy dandy spatula. So first thing that happens when we pop off the display is we'll see there is a flex over here that attaches the top, the display flex presumably. And we can see a bunch of features right away. We can see the inside of the crown assembly. We can see a battery over here. Pretty interesting. There looks like there's a bracket, like a full barrier bracket and capped on tape that wraps that battery to it. Presumably over here we have a speaker module we'll get at later. And then we can only guess that this large block over here is probably the haptic module. Earlier when we were playing with it, this thing does have haptic feedback, so likely that's a haptic module. Yeah, pretty interesting first view. A lot of cool things in here.
I can see a little bit of the layout here, but maybe let's dive a little bit deeper. I think Nihal, if you want to pull up a close-up of some of these, we can look at some of those internal components.
Yeah, absolutely. Let's do that. And everyone see my screen? Should be able to.
Yeah.
Alrighty. So this is a bit, well, first of all, if you guys are joining us for the first time and haven't seen a view of the instrumental app, this is the instrumental application, and we are a manufacturing optimization platform. We focus on trying to find and fix issues in NPI and improving quality and yield in mass production. And we do that by utilizing AI and computer vision to find different anomalies and run correlations between your data sets. So we've had the opportunity to take some images of the Pixel Watch here on the same view that David was just showing us. Right here, you can zoom in with our 21 megapixel camera, extremely high resolution. You can see even the welding on that haptic plate, and all the details and the small screws from the speaker module here. The battery here has some interesting, I guess, covering. It has some capped on tape. David, maybe you could elaborate on why that might be the case, or does anyone in the audience have an idea of why that might be there?
Yeah, I'd be curious to hear what the audience thinks. Might be some reasons for that. I have some guesses. While they're posting their guesses in the chat, let's take a quick second to answer. I think there's a question that came in from Charles. Charles asked, what kind of adhesives holding the cover glass? Is it a PUR adhesive or a foam tape? It looks like it could be a liquid adhesive. And Lucas and Vivek are also curious about the water. So we can mention that as we were tearing this down, so it looks like there is a notch in the glass. And we found something that makes me think of hot glue over in the notch. So it looks like there's a glue that's dispensed over in that region. Also, when we were tearing this apart, we found a PSA, or a pretty traditional kind of PSA seal that we delaminated. So this looks like it's a hybrid solution. It looks like it has PSA and it has some kind of hot glue looking stuff over in the notch. So that was pretty interesting.
You think it's a mixed seal where there's actually a PSA and some type of liquid dispense. That's got to be extremely difficult to get that bond between the glue, especially to get an actual water seal, because I think this thing is actually water rated. I don't recall what the rating is, but if it's at least IPX7, to get a consistent water seal between PSA and a liquid, that's got to be really tough.
Yeah, I'll take a peek here through the marketing material, see what they rated the product as. But yeah, definitely really tough to do that joint, that transition there.
Right.
Yeah.
Just curious, for other, smartwatches like Fitbit and Apple Watch, do they use only just the PSA or just liquid glue? Or is it something completely different?
That's a good question. Well, I guess one thing I didn't mention in my intro is I really like doing teardowns for fun. Kind of have this interesting hobby of teardown art. And I've taken apart a few other wearables. Most of them just have what looks like a PSA. They have like a essentially die cut adhesive films. I haven't really seen much in the way of liquid glue. So this is new. Tobias, what have you guys seen in the past?
I've seen the majority, including most of the generations of the Apple Watch, were PSAs that were die cut. A lot of attention went into surface preparation, either cleanliness or plasma treating when there was a flex to get that surface energy, because it's really about consistency of the process, making that a uniform seal. So that was PSA. We did see a really interesting one on the Fitbit, actually. It still looked like a die cut, but it was extremely difficult to remove. And we think it was actually, I think it was some sort of heat activated or laser activated adhesive where it was still die cut and put down, but then heat was applied directly around the perimeter to extra cure, because that was extremely tough. But I haven't seen full liquid, at least in the devices that we've done down here, especially not any type of hybrid seal. That seems pretty crazy to me.
Yeah, absolutely.
Going back to that battery question you put out there, Nihal, why is that battery got a full, what looks like sheet metal barrier around it and capped on tape wrapping it up? Do we have any answers in the thread?
Yeah, batteries is always an interesting one. That's what we were talking about on the Fitbit as well, because there was actually the recall due to some thermal issues, we will just say, likely related to the battery. So I know battery swelling and dimensional control. Looks like Vivek is speculating heat dissipation. Interesting. David, what do you think?
One thing that people tend to worry a lot about is drop. A lot of these consumer devices, when we first build them, the first reliability test we run through are drop testing. So my guess might be some kind of like drop protection. So as the battery jostles around or components jostle around, because you can see the gaps are quite tight, like the haptic module is quite tight to the battery. It honestly might be just to protect it from getting dinged and impacted. So that's my guess. But I'm not sure. Maybe there's a multi-purpose thing going on here.
What are those, Nihal? I almost see a couple little components. They almost look like fins to the left of the battery, to the top left. If you look at what's going on there.
It's actually a great question. Yeah, those fins are sticking straight up. Maybe we can leave this up to the audience. What do they think this fin over here is for?
It almost looks like, so it's a separate piece that's screwed in, but it's some type of metal piece that then is coming straight up. Yeah, I'd be curious from the audience if any thoughts on what the design purpose of that could be. Is there another one? I think there was another one down on the bottom side, correct?
Yes, there was.
Yeah, we got over here in the teardown one, can see two big blades sticking up. And the display's got some interesting clips that I think we've seen in the Apple Watch teardowns in the past. There's some little clips that might engage with that.
That's a good idea. Let's flip over to the display side and see if there's anything that might give us a clue to what those clips would be.
Sure. Alex suggested it might be a grounding to the chassis since it's connected to the frame. It's a pretty good guess.
Good guess. Good guess. Let's go look. Let's go look at where that connects on the other side.
Yeah, let's do that in a sec here. So as you can see with the instrumental app, we have all these different views that we've taken of the device itself. Normally, this was usually created in a way that the device was actually built so that you can see how the entire device was all put together. So here is a image. Oh, pardon me. Let me just move that back over. It's like my screen is freezing. Give me a sec here.
Looks like there's a sheet metal piece or some kind of metal piece on that display module, and you got some, I don't know, some interesting golden things over there to look like maybe those fit or they touch off with those blades.
Pardon me one second.
Yeah, it looks like it. I can share here while you work out your Chrome. It looks like, yeah, if you look at the other side of the display, I think that lines up, those two little fins line up with, what does this look like? What does this look like here? What do you guys think? Looks like one right here and maybe one right here. Do we think that this is grounding, or is this some other functional part? What do you think, David?
Yeah, that's a good question. I mean, Alex's guess here on grounding seems pretty good. One other thing to think about is a lot of these products now have like Wi-Fi, Bluetooth, LTE functionality. So I know in the past, some of the, like looking at some of the Apple Watch stuff, their antenna is actually on the top, and antennas don't tend to radiate well out of metal housings. So usually they want to be kind of near where there's RF transparent material. So maybe there's something antenna going on here. That would be another guess. Maybe they're actually both. We got some grounding and antenna stuff happening.
I think that's a very good hypothesis here, because I know in a lot of the other smart wearables as well, the front face is a great spot for LTE antennas because less interference from the wrist or other objects. Putting it on the back is always risky because depending on the contact with the wrist, it can screw with the signal there. All right, let's one more thing that I noticed over here before I hand it back to Nihal. This crown here, this is something that caught my attention, because back on the Apple Watch, I know this was a very different design, but was also a huge problem area. What do we think is going on? So it looks like we have the rotating shaft, and I see the dome switch here, which clicks it in, but then there's this intermediate, it almost looks like a little metal piece here and a gap that then winds down and connects over somewhere here on the left. Any ideas from the audience on what this little metal piece might be? What do you think, David?
Yeah, no, that's a good one. Alex brought up like maybe there's some kind of grounding. I was reading through some of the, maybe there's grounding going on here, but I was actually reading through some of the marketing material, and there's health sensing functionalities. I know in my Apple Watch, I can touch the crown and it'll take an ECG measurement. So presumably I'm touching some kind of electrode. So maybe there's something about passing an electrical signal through. Also, yeah, maybe, I mean, it's kind of hard to tell from this view, but there's some guesses here on like retaining spring, maybe like helps hold something in place, or maybe biases the crown back out. Yeah, those are some of my guesses. Probably leading one is like health sensor related.
Yeah, I think the audience is on the right track here. Retaining spring steel. My guess from working with the crown on Apple Watch, I think it's actually doing double duty here. Yes, it is the retaining spring to keep the tension on the crown, but to your point, David, for the ECG sensor, so on the back there's electrodes that measure your left arm, but you need a signal on your right arm, which is touching the crown for this one. So there's actually an electrical signal that runs through the spring. And I remember how tricky it was to get a rotating electrical contact to be consistent over millions of clicks and rotations. And I remember specifically going into higher volumes, the consistency, we had a tester at the end of the line, the consistency of that was all over the place. And over time, the test values would drift. And then we had to go jump in and figure out, was it the process that drifted? Was it the conductive grease? Was it the tension on that? And we were always being super reactive. And maybe actually this would be a good time to show Nihal some of the test data features that we're actually able to take an instrumental.
Yeah, absolutely. Let me do that right now. Oh, pardon me, wrong screen.
Well, that's coming up. I'm over here. I'm starting to dig into the teardown. I'm starting to pull some of the components apart. I so far pulled apart a cowling that probably holds down some speaker related stuff, and 2 of these blade contacts that we speculated were for grounding and maybe antenna related things. So those are coming out. Yeah, gonna keep digging in.
Yeah, so as Tobias was mentioning, that's a lot of data to go over and make sure that it stays within specifications. The Instrumental's application has a great new feature that just came out, where we have SPC and control charts. So for all those tests that Tobias was running on the Apple Watch, make sure that those values stayed within limits over the course of hundreds of thousands, if not millions of units. Instrumental would be able to give you statistical process control and actually look into these control charts and see if these values were drifting out of spec, and even send you notifications and alerts to show you, hey, your process is drifting, please go ahead and take a look, as well as, any average CPK, PPK values that you guys wanted to know. Once we actually know that something is drifting and you're like, hey, this is a value that's relevant to me, or test parameter that's relevant to me, you can correlate that drifting parameter against all other variables to see how things are going. With Instrumental's app, you'd be able to simply click correlate, and Instrumental would go through using its AI and correlate all of these variables against one another, or relevant variables that matter to your test. In this particular example, we have a failing Bluetooth antenna test. And as we know, in consumer electronics, Bluetooth antenna tests are notoriously difficult to resolve and evaluate. So right here, Instrumental is going through and correlating the Bluetooth antenna test failure with firmware version 1.64. And it's showing you that, hey, the most likely correlated reason for your antenna test failing is because you uploaded this new firmware version. And or it could be a supplier. A lot of the times we use multiple different suppliers to make sure that our assembly process continues smoothly. And in this case, Instrumental is highlighting that, hey, every time you use the Molex supplier, you tend to find more failures with your Bluetooth antenna than whenever you use the Amphenol supplier. Maybe I can pose this out to the audience here. How do you guys feel like you'd be able to utilize this in some of your applications where you guys work?
Yeah, I'd love to hear from others as well. Thanks for sharing, Nihal. I know, yeah, for me, just the root cause analysis, looking for what caused that drift, was just such a large portion of where our product design team spent our time. Well, we're waiting to hear from the audience here. Let's hop back to see where David's at with, looks like you're going after that battery there.
Yeah, so haptic module's out. Battery's been, all the screws that hold this battery assembly have been taken off. And so when you lift out the battery, you can see there's a service flex for the battery right there. And it is a nice big sheet metal piece that goes all the way around, and it's all wrapped up in this Kapton tape. I'm gonna go ahead and try to get one of these screws over here that's at quite an interesting angle. You can see it right there. It's pretty interesting, the amount of complexity CNC wise that you see in a lot of these tiny parts and all these different angles that they're putting threaded holes at. This is pretty impressive to see. So this cowling's coming off. So that guy, we'll put him over here. We got the battery connector. So that's out. And then we have another connector over here. That guy's coming off. Looks like that goes to a board. And hopefully we can pry this off without breaking anything. It looks like something's kind of stuck in there. It doesn't want to come out.
Is that the speaker board on the side there, David, that you're prying off now?
Yeah, that's a good question. So this looks like a board that is behind the speaker. And I see. So there's a board that backs up the speaker. And it looks like we have, pretty interesting, there's two gold contacts here that line up with some spring fingers on the back of the what presumably is the speaker module. I bet if we try to get this thing out, it's really in there. All right, so the speaker module's out. There it is. And there's a cavity in there. We can see there's some kind of mesh on the speaker. There's probably, looks like there's kind of a seal around the edge to seal into the cavity. And then pretty interesting, there's another hole right here next to the speaker where I'm pointing over here. And that is where we were having trouble getting this board off. There's this little kind of like metal tube volcano looking thing with maybe like an O-ring on it. This is probably some kind of sensor. I'm going to guess like we have usually altimeters on these kinds of things to measure steps and how many floors you're climbing. So maybe that's what that is. But yeah, speakers out. Some kind of board over here is out, probably audio related and sensor related. And then we have maybe one more connector we can access, and that is the display connector, it looks like. So display connector is coming off. And there we go. Display module is free. Yeah. We got some interesting stuff going on here. Down here, presumably, is the main board, the kind of main logic board. And there's a sheet metal piece, usually used for shielding components. There's a shield can. It's quite a fancy looking design, quite a fancy shape here. And there's some copper pieces on here. I wonder, what do folks think? What might these copper pieces be used for? Like, why do they have, copper rectangle here, a couple circles? I wonder what those are all about. And I think we might have a better image we can show on the instrumental.
Absolutely. Yeah, you want to pull it up there so we can take a look. Yeah, that is really interesting. So it looks like the shield can, there's what looks like a die cut adhesive. Was that for the battery tray, I believe, that went right on top of the shield can there?
Yeah, I had to really pry to get that battery off. So presumably that's the PSA that holds it down.
So it's got a pretty solid adhesive there, but again, cutouts around what looks like 4 little copper tapes on top of the shield can. Maybe we'll take those off in a second here. Any guesses from the audience on what those are? I also see, Nihal, coming back to the question about those ground connections that were made to the display. We were debating, is that an antenna connection? Is it a ground connection? Can we look in those 2 little pockets to see where those, right down there, to see what that's connecting to?
Yeah, it's like, can you see that? Yeah, it looks like it.
Yeah, that almost looks like a spring, an antenna spring finger going straight onto the MLB there. I've seen a lot of those get damaged during assembly. That's one thing that a lot of our customers, especially when they're on exposed PCBs, if that's bent just a little bit, then you won't make proper contact with the antenna path. So what do you think, David? What do you think that tells us if that's connected? Because it looks like that's actually connected to the MLB and not the housing. What does that tell us about what that path was?
Probably it probably narrows it down that it's antenna related. Looking closer at these little parts that have the blades on them, they have a metal contact on the bottom. So it's like a insert molded, it looks like some kind of insert molded part. So yeah, likely this is just, these components are a pass through for the antenna signal. Yeah, I think that probably helps us narrow it down.
Awesome. Share my screen again.
Yeah, neat. Those are pretty tiny, 2 of them there.
Yeah, those are.
Yeah, going back to those copper tapes, we still don't have any guesses from folks. I think we do have an image of it where the copper tapes are off. Maybe if we show that, it might inspire some answers.
There we
Okay,
go.
cool. So they're just exposed holes into the PCB. You can see some components maybe, or some, looks like some,
Yeah, you can see some
copper.
components down there.
Yeah.
Yeah, Jeremy was guessing shielding. That was my first thought too, was again, maybe one of the purposes for the shield in the first place is shielding. And if they had an alternate reason to put the holes, they wanted to cover it up to get that continuous EMI shield. Are there, yeah, David, you were saying the points under there, are there actually test points that were the original reason to leave those holes exposed? Is there anything we can see?
Yeah, that's like, it's a good question. Actually, Jeremy that just responded, him and I worked together in the past, and we it always came up that where sometimes when you surface mount the shield can on, you still want to be able to test certain things. And once you put the shield can on, it's hard to test certain things. So test points is usually a guess I go for in these cases. Yeah, it's nice to be able to still test some things, and you can put the copper tape on it and make sure you have the right EMI protection, the kind of electromagnetic interference protection, or some folks call it desense. Yeah, I think probably a double-sided thing here. You want to be able to test some stuff, and then you want to still be able to protect from EMI desense.
Yeah, I think you're right. Anything else I want to hear from the audience as well in this view here? Any specific components or modules that you guys want us to dive in on? I know David talked a little bit about the speaker over on the left-hand side. We can see the little port. I think that's, we talked about the altimeter port there.
Yeah,
I'm just impressed with the intricacy of the housing and all of the crazy CNC steps that must have had to happen to make all these little undercuts. And yeah, I just can't imagine the cost and process optimization that went into this. Anything else, David, that you want to highlight here before I think we're almost ready to flip over to the back side so that we can try to get at the main board here?
Yeah, probably I'll show it on my screen. There's probably 2 last things to just call out. There's a flex that is stuck to, that looks like it's got some solder joints. And on the opposite side, we have the sort of band attached port, or the band attached slot. And this looks like a debug connector probably. I know on Apple Watch in the past, there used to be some similar thing, and that was used for debug. So we have this flex here that's going into the debug connector, and we'll come back to this later, but this whole assembly here, we're not quite sure how to pull this out yet. It looks like there's the crown, some kind of component here, tack switch over here. So we'll come back to this, but yeah, I think Tobias, we're ready to flip it over.
Sure, absolutely. I was actually curious. Earlier, someone had mentioned that maybe the little hole on the side was actually for a reset. Is that hole exactly where the altimeter is?
Yeah, that's actually a good point. So if we go over here to the component we think is the altimeter, and we look on the flip side, there is a hole there. So that's probably for the altimeter. I wouldn't want to jam any needles or anything to try to reset stuff in there. You might break something. I've heard some stories of folks doing that before, so I would not advise trying to reset, but it's a good guess. And then over here, there is another hole. I think we'll probably find out what that's for later. If I had to guess, there must be a mic on here for using the Google Assistant. So either that's probably the mic port there, but yeah, we'll come back to that one.
Sure, absolutely.
The back health sensor that you mentioned before, David, it has a lot of similarities to the Apple Watch. It looks like it has an LED emitter and a couple different photodiodes, and then very similar on the two electrodes for the ECG. The pattern looks a little bit different for the optical sensor. And one thing that's very different, the Apple Watch, we spent a lot of time putting lenses over the health sensors to mostly for cosmetics, for the industrial design, so that you didn't directly see the electronics. And I think that was something unique that Apple did, was spend so much time obscuring that little health sensor underneath.
Yeah, with Apple's attention to detail, I can only imagine. You can almost, when the product's still assembled, you can see the LED component and all its tiny detail in there. So I imagine at Apple that's definitely a no-no. So jumping ahead here, this bottom glass piece, again, another pretty exotic piece of glass. It is 3D on both inside and outside. It's got those shiny surfaces that are probably some kind of metallic coating. Usually folks will like PVD this on. That's the process to get it on. And then on the back side, there's some pretty interesting pad printing, some probably conductive pads here that line up with these little conductive foams over here. That's probably part of the health sensing you mentioned earlier, Tobias. And there is a pretty interesting flowery pattern on this bottom glass part here. I don't know if folks have any guesses on like what is this? Looks like some kind of sticker with some slits in it. They got put on the backside of this. I don't know if folks have any guesses on what's going on back here. Would love to hear in the thread if you get a chance.
Yeah, there's a couple different ink layers. I almost see 3 or 4 different layers that were printed on. There's the external layer on the backside, which is the conductive ECG. And then it looks like those little exposed pads, the 2 little silver pads, is the internal connection. Looks like Jen is guessing here is that spiderweb pattern, is it to limit the amount of light that's coming through the readings? That is a good guess, because light leakage is a very real concern, both ambient light leakage. I remember doing studies where in strong sunlight, if your watch is too loose, the sunlight can actually seep in through some of the ink in the back and saturate some of the sensors. So it could be that, but it looks like there is a black layer of ink across the whole glass, and then there's this extra layer on top as well. I'm wondering, would there be any chance that it's structural at all? I know one thing that we were always concerned about is when something does crack, what the mechanism is. Like, does it actually chip or does it fully shatter? So that might be a little far out here, but it could, it almost reminds me of like a shatterproof film on some other like automotive or vehicles that I've seen before. What do you think, David?
I'd probably agree with you. This is pretty thin glass. If I have a pair of calipers over here, if I measure, yeah, it's like 1.2 millimeters thick. I can imagine that this thing might not be the best at like not survive the best in drop. So maybe, yeah, maybe a film to help keep the glass together if it breaks, so it doesn't end up cutting you if you do pick it up once it's broken. On the display side, that's not going to be an issue because it's all glued to the display. But yeah, that seems like a good guess, Tobias.
How do they, yeah, let's talk about these glass designs for a second. I know we had a question around the industrial design around the glass, this circular 3D 3D curvature looks pretty complex. And on the back side, again, as well, very thin throughout. How do we think they actually manufactured these glass parts? Any guesses from the audience on how we get these complex 3D shapes and the notch there on the front cover? Yeah, David, what are your thoughts based on your experience on glass manufacturing?
Well, yeah, I'd love to hear what the audience thinks, but glass, that is that is a long lead time topic and a very expensive topic. Usually, just like in past experience, if we want to do fancy things with glass like this, we're basically machining glass. We're slowly cutting away glass, and it's very expensive to get to these shapes. And you can get really good dimensional control, and you can get these fancy shapes, and then you can polish it. I have also seen in the past another big category is thermoforming. So they'll basically heat up glass and just let it relax over a certain mold, a certain shape. So yeah, it could be thermoforming, maybe a combination of thermoforming and probably machining, polishing. It just depends on how much the folks over at Google wanted to spend on this. So yeah, usually comes in those two flavors. Maybe there's some other exotic stuff, but those are the things I've run into.
I've mostly seen just machining of the glass. The thermoforming is very interesting. I know when we were looking at glass geometries, as well as the processes, a lot of focus was put on the material properties. You mentioned dimensional control being one of the big trade-offs of CNC versus thermoforming, but I would imagine that the material properties, how resilient it is to both drop or scratching or other impacts, how does that get affected by a process like thermoforming instead of CNCing Corning goes through all these processes to harden the glass. Do those advanced properties remain after the thermoforming?
Yeah, no, that's a good question. I'm not a glass expert, but from what I can recall in the past working with some glass experts, typically if you're superheating glass to form it, you don't quite get as good mechanical properties. So that's another good call out. I think you probably sacrifice some of the mechanical performance. So maybe that shows itself in drop or scratch resistance, probably more drop, to be honest. So yeah, that sounds right.
Yeah, that looks like a really complex process to hone in on that display there, especially with the 3D curvature and the notch.
This notch is wild.
Speaking of that notch, how tight of a tolerance do you think they need to have to, I mean, if they're assuming they thermoform that glass, then on top of that, they need to polish it and make sure that's within tolerance. Do you think they have a pretty big tolerance gap there? I'm assuming it'd have to be really tight to make sure that the waterproofing was good.
Yeah, I think you're onto something. Not sure what kind of tolerances, if they're in the sub, a couple 100 microns or 50 microns, but they're definitely holding some really tight tolerances because water sealing is just, yeah, it's really tough when you're trying to do kind of a 150-foot, underwater sealing. So I can imagine it somewhere in the 100 microns or less, somewhere around there probably. And that probably makes this part quite expensive. So definitely some trade-offs to think about when you're designing. I bet the industrial designers and the product designers had a few debates over how to put this together.
Yeah.
Let's we got just a few minutes left here. I want to make sure we get to dive into the backside of the watch that you just popped open here. So number one, from the audience here, there's a lot of things that we could still dive into. We've got the back health sensor. We've got potentially some other components on the back side. The housing band slots, we could take a deeper look at the display. So let us know if there's one last thing you want us to dive into. And then maybe Nihal, if you want to pull up a close-up view of that backside, we can look at that health sensor there and see if there's anything interesting.
There you go. So right here in the middle, we have the health sensors and an LED. We've got these two leads here. Maybe we can leave this up to the audience. What do we think that they're for?
Yeah, interesting. Those look like they're probably hand soldered. They look like quite beefy solders.
Right.
Else here looks so tiny.
Yeah, looks like Jeremy's got a pretty good guess here. The wireless charging. Jen was guessing RF or wireless. I'm pretty certain that this is the wireless charging. I don't think anyone's tried to use the charging coil as an antenna, but I could be wrong. There was a lot of experimentation around using different components as antennas back in the early days. Yeah, I think this is a pretty standard wireless charging, just for it to go on the puck. But yeah, those hand solder joints, those are always pretty finicky to tune in that process. Looks like those are getting dangerously close to each other. I would be a little bit concerned if those shorted, because that's actually a power circuit. And so if those two shorted, you're going to have some serious thermal issues when you put that on the puck. The LED there, what's that? It almost looks like a foam piece around it. That reminds me of the question that we had before around preventing light from getting into those other photodiodes. And this actually reminds me of designing the Apple Watch as well. We spent a lot of time trying to prevent light leakage from getting from the LED, short circuiting straight to the photodiode. That looks like a pretty tricky, probably manual assembly there of that foam gasket. What do you think, Nihal?
Yeah, that's got to be incredibly difficult to actually maintain. It seems like you have probably had an operator cutting these out of a little foam just pad and sticking it on top. That's maybe a couple millimeters. And I don't know if they have any adhesive on the bottom of it, but there's a very good chance it might move as the operator is trying to put it on. That actually reminds me, with instrumental, you'd be able to capture anomalies like this, this foam padding preventing the light from diffusing into the health sensors. I'd love to show you guys a little bit about how instrumental would be able to do that. Just give me 2 seconds to hop into the app.
The best one would be catching some operator forgot to add the foam. That one's always entertaining to debug. Hey, there's a missing part here.
Yeah, I remember too, because you would hope that would fail the functional test. I think the missing one, I would hope would get caught by the functional tests. What we spent weeks debugging was, oh, the foam is just a little bit shifted, or the foam was covering the LED a little bit, so the overall power output wasn't quite as high. Kind of those marginal cases that were really hard.
So right here on the Rilo 360, we have a foam covering this LED, and a lot of the times with manufacturing, we run into the problem of knowing that there is a problem, but we don't know how many other units that problem might have impacted. So with instrumental, you can sort and search your units by most anomalous, and it'll highlight for you. This is our friend Norm here, by the way. He does most of our analysis for us. Over Halloween, he was wearing a little bit of a pumpkin. and it'll highlight for you where all the anomalies are in each of your products. So right here, you can see because these units are serialized, you're able to find out which units, as you said, David, might have a missing foam or slightly off, covering it a little bit. And you'd be able to even see if there was some sort of corrosion or glue on this foam or this unit. And say this was something that like you had to make sure didn't happen. And of course, it is something, especially on a thing like the Google Watch, you had to make sure that the foam was in the right place. You'd be able to monitor something like this to make sure that it never happened again, and train the AI to learn what was anomalous and what had failed. So you'd be able to fail all of these units and make sure to capture that on the line before your unit ever passed through and had any escapes.
Wow, yeah. This would have saved us a lot of time and headaches back in the original development cycle here. Thanks,
Yeah.
Nihal. Should we maybe just one more thing? I saw right around that charging coil, David, what was that? It looked like there was one more concentric piece that I couldn't quite figure out what it was on the backside.
Yeah, that is a good question. I've torn down a little more here. And so now we have there's a flex that has all the health sensor stuff on it with a magnet on the back. Got the charging coil over here. Bunch of screws. We'll get to the MLB in a bit with the housing. And then there's this plastic piece that has these insert molded feet. This is interesting. I am not sure what to make of this. Kind of some things that come to mind would be maybe they're filling in space where they just needed to fill in space for drop performance, so that the glass part over here has something to back up against when it's dropping. I know there's like a couple versions of this watch. There's like a Wi-Fi version and an LTE and probably multiple. So I don't know, maybe they use this for something antenna related later. But yeah, just these are some of my guesses, like structural or maybe antenna. But then again, we have antenna stuff on the top. So yeah, I'd love to hear from the audience to see also maybe some of their thoughts. But yeah, what do you guys think?
I'm curious if other people have thoughts. I think you're onto something there. When I first saw it, I assumed it was a backside antenna, because again, in a lot of these wearables, there's either a couple different frequency bands of LTE for different regions. But looking closer, it didn't look like there were that many active components on it. I was assuming it was some kind of LDS with the antenna molded into plastic, but it might actually be because of the skew. This might actually be the Wi-Fi skew, and so it might not actually have the antenna. So it might be a filler piece for this specific model here. That's what I'm thinking, because it looks like it probably is an antenna in some models. All right, I know we're just about out of time here. We had some great questions on measurements around that LED foam, which actually is a perfect use case, both like the shifting around of it, and it is something that Instrumental actually has just released into beta. I don't know if we have time today to show the full demonstration, but if you're curious to see the full instrumental measurements, it's actually pretty cool, because you can go back through thousands of units and actually retroactively measure a whole bunch of devices. So if that foam was maybe causing some light leakage issues, but you didn't know it at first, you could actually go back through even tens of thousands of units and measure how the width of that foam then correlates to the performance of your health sensor. So we've just released this into beta, and yeah, if you want the demo, we can set up a time. Just reach out to communications at Instrumental. Anything else? Final questions? I think we just about tore this down. We didn't get the full MLB out, but I think we covered most of the main pieces on there. David or Nihal, Any last thoughts on that MLB? Oh, there we go.
There she goes. MLB's got a nice can on the top. There's another shield can on the bottom. I believe we tore down another one and we have some cool images if we get to share them.
They're right here.
Oh,
But
there
yeah,
we
no,
go.
that
So
yeah,
this
that
is
pretty much does it.
top side, right where that can comes off. You can see that outline over here all the way around. Excuse me. And then you have all the board-to-board connectors and the springs right here in the corners. If you flip that over, this is the backside. This is under those health sensors. You see a bunch of, LED SMT components and more board-to-board connectors. It is pretty fascinating how these MLB boards are made and how intricate they are.
But yeah, it definitely looks like they utilized the space pretty well, which is critical for a small design like this. Jen brought up a great use case around the reliability team. And again, that was a lot of where we spent our time at Apple, is debugging why these 2% of units failed the drop test or the water sealing test. And yeah, having data records like this from time zero, that would have been incredible for ruling out, determining, was it a design issue or was it a process issue? So that's a great use case. A lot of our customers are really focusing on debugging those reliability failures as well. All right, I think that puts us just at time here. I like that combo shot that you have here, David, nicely laid out. Thank you everyone for joining. As we posted, we're actually doing into the new year a viewer's choice teardown. So this is actually how we pick our teardowns, is we want feedback from you guys. We just did the watch here. What do you guys want to see next? We did a couple Sonoses in the past. We did the Xbox. So please fill out that survey and let us know. January 19th is the date. Thank you again. Huge thanks to David for leading us in this Pixel Watch teardown, sharing his wealth of knowledge, to Nihal, the rest of Team Teardown, and for you guys in the community here for sharing all of your knowledge. We will see you guys next time on Change Notice. Thanks.
Thank you.
Thanks.
Manufacturing has changed, and hitting yield targets, deadlines, and quality goals is harder than ever. Instrumental is the first manufacturing optimization platform designed to help both engineering and operations teams ramp successfully on every program by finding and fixing issues at the source and making sure they don't come back. From development through mass production, Instrumental is helping the world's most innovative brands and contract manufacturers accelerate failure analysis and drive continuous improvement by easily unifying their product data into one secure cloud-based hub. And you can get started in less than 1 week. Using images, video, machine parameters, functional tests, measurements, supplier and return center data, Instrumental makes collecting data and finding correlations easy. Our AI surfaces the most meaningful relationships among your data sets, so you can find the root cause fast. Starting with your first build, Instrumental proactively identifies new issues by scanning your products for anomalies in visual or functional test data and automatically delivering net new discoveries. In development, engineers can jumpstart failure analysis with defects in context by leveraging a rich, remote data set. With Instrumental, they can quickly identify correlations and potential root causes, and even push live tests to validate solutions immediately, eliminating issues at the source. In mass production, you can monitor throughout, get alerted of shifts, and identify correlations to root cause, unexpected drift, redundant tests, and operator issues. When installed across factories in a supply chain, brands and suppliers are able to stop working against each other and start working together to solve their most complex issues. Better products start with better data. Better products start with Instrumental. Schedule a demo today.